Alright, 1.1 backside. Here we go. Name 3 points. Yes, there's all kinds of letters in here, but H is not a point. C is not a point. It doesn't have a point associated. So any of these points, name 3 points. Point A, point B, point G. Sure, it's alright. You can write that down on your own. Name 2 lines. Now there's all sorts of lines in here. Even though there's only 2 lines drawn, I can connect any point. So there's technically a line DE. Even though it's not drawn, it exists. There's somewhere in our minds we can see a line going through D and E. Alright, so name 2 lines. I'll do this one. I'll do the ones that are drawn. We have line FE. Don't just say FE. That means something different. And we have line AB. Name all points in plane H. So here's plane H, F, E, and D. Name the plane that contains points A, B, and G. So points A, B, and G. There's lots of ways to name this plane. You could use these 3 letters, or you could just call it plane C. You can't call it plane A. You can't call it plane B. You can't call it plane G. You can use the non-point associated letter to name it. And then the last question here, are points F, D, and B collinear? So here's F, D, and B. Alright, this is a tricky question. Are these points all on plane H? No. Are these points all on plane C? No. However, is there a plane that exists in our mind that does connect these 3 points? Could a spider spin a web between these 3 points? The answer is yes. Because we learned on the first line, any 3 non-collinear points, which these are, there exists a plane. You can make a flat surface through there. Okay, remember, any 3 non-collinear points, you can make a plane. That's a tricky one. You gotta watch out for those. Okay, next. Use diagram. Name a pair of opposite rays. So we could say, starting at point E, we could say ray EC, and then going the opposite direction, starting at E, going through D. Notice the markings that I'm using here. Notice that they both start at E. Those are opposite rays. Name 2 points that are collinear with point D. So on the same line as point D. So it'd be C and E. Name a point of intersection with line CD. Here we got a little lazy because it's hard to do this when you're typing it out. Line CD and plane A. So where's this line shooting through the plane like I did here? Where's that point of intersection? And it would be right there at point E. Name a point that is not coplanar with plane A. So not on plane A. So it's either going to be above the plane or below the plane. So both C and D are not on plane A. And there might be multiple answers for this. Next, give one other name for line MN. I don't even need to look at the picture. I could just flip it around. Oops, I didn't flip that, did I? We could call it line NM. It's the same thing. It goes through both of those points and it goes forever. Let's see. Or there is a little S. You can call it line S. Or you bring P into it. Line MN is this line here. You could also use line NP. You could bring P into it. There's all sorts of names. It's the same line. You could use line MP. That's the same line. Name 3 points that are collinear. M, N, and P. Also, T, N, and W are collinear. Name 3 points that are coplanar. 3 points that are coplanar. Alright, we just got to name 3 points that are not on the same line. So M, N, and P, we don't want to use those because those make a line. Let's use M, V, and N. And technically, you can use any 3 points. You could use M, V, and T to name a plane. So technically, there is a spider web there. Right. Name a point that is not coplanar with points N, P, and T. This one's tricky now. N, P, and T. Is M on that plane? So imagine I've got a nice plane here now. I'm drawing a new plane. M is on that plane. And so is W. That's really hard to see. But the answer to this is V. N, P, and T, when they cross, they're making this plane, right? They're making this like this surface. So M is on that, and so is W. V is the answer to this. That's a really tough one. And those show up. Some of them are easy, some of them are tough. All right, here we've got a three-dimensional cube, even though it's drawn on a two-dimensional surface. Kind of, you can see 3 dimensions here. Name a point that is coplanar with A, D, and G. So A, D, and G. Now, these 3 points are representing this bottom of this cube. So anything on the bottom of this cube is on the surface made by A, D, and G. So we could say L or F. Points L or F. Alright. Name a point that is coplanar with B, H, and D. Now this one, we got B, H, and D. So this one's we're gonna have to shoot this through the cube. And that would end up looking like this. So B, H, and D. This is a tough one. But technically, we could draw a plane that would shoot through the middle. And it would also contain point F. Name the intersection of planes HEG. So let me erase this real quick. HEG. Go ahead and try to figure out what plane HEG is. So HEG. That'd be like this back plane. And plane DFE, that'd be like this side plane. So where is the back intersecting the side? That is right here. Right here is where they intersect. And 2 planes will always intersect to make a line. Because remember, we gotta think of these as they're going forever. So actually, they're going forever here. So that's line EF. The answer to the intersection of planes is always a line. Name a point that is collinear with line BM. So here's BM, and that goes forever, and includes H. And then lastly, name a point that is not coplanar with C, E, and M. Not coplanar. Well, I'm gumming up my picture now, but C, E, and M, that's this top plane. So basically name any point that's not on the top plane, so you can name any of these. So A would be an example of not coplanar. And then here we just have some ways that planes can intersect. Here's parallel planes. So these are not intersecting each other, like parallel universes. But what if parallel universes did intersect? That'd be fun. Next, we have planes can intersect like this at a line. You get multiple planes intersecting. planes could intersect at multiple lines, but then have a master intersection plane. And this is like your, I don't want to get into that. Planes intersecting, there's your planes intersecting. Alright, that is it for 1.1.